We are going to discuss about the steady state response of the single area low frequency control uncontrolled cases. Okay, already I explained about that one. So what especially for in this unit, there is a real power versus frequency control. Why we are going to maintain the frequencies? I already explained about that one. In a power generating station, for in a generators, we have to maintain the speed. Unless if the speed is not be maintained, there will be a frequency distortions will be produced as well as the frequency changes will be produced. Ns equal to 120 f by p, the general formula. So for in these cases we are the conditions to maintain the frequencies. So for in this unit, the one of the important derivation is what? A steady state responses of the single area low frequency control, that is the uncontrolled cases. So in this uncontrolled cases, so this model is belongs to, it is a speed governor model, and this one is nothing but, you know that this one is your turbine model, and this one is your generator model. So in these cases, so for uncontrolled case, what is meant by uncontrolled case? So below that, this is the basic diagram where we initiated means from the help of that general block diagrams in the generated model, turbine model, as well as the frequencies, that is speed governor model. So based upon that particles, based upon the content, we are drawn the block diagram with the help of these three different models. Okay, just I have to remind that one. So this belongs to the speed governor model, and this one belongs to the turbine model, and this one belongs to the generated models. Okay, so here it is a control. This is PD is nothing but what? A demand powers, and this one is a control powers. So for in these cases, uncontrolled cases means what? So here demands that should not be in our hand. So if you want to run the generators in a previous speed, we have to give the what we are in the conditions to improve the turbine speed. Okay, for in order to improve the turbine speed, we have to produce the water. We have to produce the more steams. So therefore, demand power should not be in our controlled cases. So therefore, in uncontrolled parameters, just to read these statements. Consider the speed changes as a fixed setting. Under this condition, del P is equal to 0 and the load demand changes. This is known the free governor operation. So from the below block diagram, it's shown that del P is equal to 0 for the uncontrolled cases. So likewise, so this is the cases. In these cases, del PC equal to 0. Okay, so uncontrolled cases, we are kept only the demand powers. PC is considered as the 0. Got it? So therefore, if we are substituting the parameters, then the block representation will be like that. So here is the speed governor model and the turbine model as well as the generator model also there. And this one is for a representation. For this one, we are going to consider the first order system. We know that why we are going to compress that block, compress that power system into the simple block diagram means we have to numerous parameters we are the conditions to analyze. So in order to reduce that, in order to make it in simpler cases, we have to combine this model into a simple cases, a block diagram as well as like a control system explanations. So based upon that, we are going to convert it into the first order system. That means what? A single area means what? We know that a single input as a single output. Okay, we are going to modify this one. With the help of this block diagram, we are going to modify as here. Here already we know that, okay, for two inputs, okay, multiple inputs and one output. Okay, so we are the conditions to rectify and convert it into the single inputs. Okay, for example, here also one input, here also turbine power also, generating power also one input, demand power also one input. Okay, two inputs and one output. So in order to, in a first order system, we have to reduce these two input into the single input and one output stages. So therefore, the block diagram should be represented in the form of what? Transfer function. Okay, so that means here the demand power should be as a input, and this one kV by 1 plus STP into this two is combined together as like a series, and we are going to merge kg kt divided by r. This one minus 1 by r is equal to the numerator, so r 1 plus stg into 1 plus stt. So in order to write the first order equation, we have represented this block diagram should be a single input and single output from the multiple input stages. So now, So we are writing this function will be in the transformer in the form of the transformer function. So that is transformer function equal to g of x plus 1 plus g of x into h of x as a first order system parameters we have to write. So therefore this one is what g of x parameters and this one is a h of x parameters. So g of x is nothing but kb by 1 plus stp plus 1 plus this g of x is nothing but kp by 1 plus stp into h of x is this parameters. So these parameters we are going to consider as a h of x and write in the terms of water. So likewise is kt divided by r into 1 plus stg plus 1 plus stt. Okay, so now so if we are going to substitute the further equations, it will be like what del f of x. So kp divided by the obtained equations will be arrived. So the difference between the static and dynamic, I already told that. So static and dynamic characteristics plays a vital role in the low frequency control. Okay. For in these cases, a static means for the same equation, first order means we have to give us a one input and one output. Okay. For two area system means two inputs and one output. Okay. Because in a two area system, if the generators will be in a enhanced manner means we have to go for the two generating sessions. Moreover, in a generating sessions, we run the generator, two or three more generators will be running in parallel stages. Okay. For in a static characteristic, explain the basic difference is what during this derivation we have to apply, we have to we have to construct this block diagram. Afterwards, apply the transfer function. Then we have to go for some input changes we are going to consider, and then we have to apply the final value theorem for the respective equations. Okay, we have to apply the final value theorem for the respective equation, and finally we have to find out the change in frequency value. And this cases for this is the final formula for the single area. Okay, if we are going to substitute all the parameters to the above equations, finally we got the change in frequencies